Welcome to 2.4, Marginal Analysis. This one's for you business majors. Life sciences folks, what a fun opportunity for you to learn something new that your classmates are interested in. In this section, we'll be using what we learned in section 2.3 to find derivatives, but the functions are not tricky to differentiate. What is challenging in the section is that you're just asked to remember what the profit and cost and revenue functions are and how they work together, and some really specific economics theories. But I'll try to highlight the key points and keep it as simple as possible. Let's start with some definitions. C of x is your cost function. It's the cost of producing x units. R of x is the revenue function, the revenue from selling x units. P of x is the profit function, and you get that by subtracting your costs from your revenue. Some money left over that you get to keep, hopefully. All right, when you differentiate that cost function, you get the marginal cost function. It's the rate of change of cost when you're producing x units, so it's how the cost function is changing. Very much like the definition of the derivative. And we can use that marginal cost function to approximate the difference in the cost of making x plus 1 units versus making x units. Tell you what, let's look at an example. All right, let's say we have a cost function of 5x squared plus 1200. That is the cost of creating x units. So the cost of making 20 units then would be C of 20, and that comes out to $3,200. The cost of making 21 units then would be C of 21, and that comes out to slightly more, $3,405. Okay, so if the cost of making 20 units is $3,200 and the cost of making 21 units is $3,405, then their difference, the difference between those two numbers, $205, well, that's the cost of making the 21st unit. Now let's use the marginal cost function to approximate the cost of making the 21st unit. All right, so remember that our cost function is 5x squared plus 1200, and that the marginal cost function can approximate what we just found. So what we want to find is c prime of x, which in this case, because we know how to differentiate, is 10x. It's just 2 times 5, right, times x to the 2 minus 1 power, using the power rule. All right, so c prime of 20, which is the marginal cost of the 20th unit, is just 10 times 20. We're just plugging in 20 for c prime of x, which 10 times 20 is $200, which you must admit is a darn good approximation to $205. In this case, we didn't save ourselves a whole lot of work, but you can imagine if the cost function is more complicated and we've got bigger numbers, then we're going to save ourselves a whole lot of work by making this approximation. All right, let's get a few more definitions. In addition to the marginal cost, we can have marginal revenue, which is just R prime of x, or the marginal profit function, which is P prime of x. The demand function is D of x. Manufacturers can use the demand function to set their price, P. If they do use D of x for P, then you can find the revenue function by multiplying the price that they charge by the number of items that they sell. So x times P. Or if P is D of x, then it's just x times D of x. Another calculation you might want is the average cost, C bar, of x. If the cost of making x items is C of x, then the average cost of making one item is C of x divided by x. Right? You take the total cost and divide by the number of items, and that gives you the average cost per item. Of course, if you want the marginal average cost, you can differentiate C bar of x to find C bar prime of x. This function gives the approximate change in average cost if you make one more unit. The last application we'll consider in this marginal analysis section is the marginal propensity to consume. It deals with the spending and saving habits of a whole country. So first we'll let x be the total income of the people of the country for 1 year. Then C of x describes the country's consumption of goods. That is to say, how much money people are spending on stuff. Please, it's really important to notice that this c of x is a different c of x than the cost function that we've been talking about earlier in the section. Okay, then we can call S of x the country's total savings. So the whole system can be described as the national income x is equal to the amount of money people are spending on stuff, c of x, plus the amount of money that people are saving, s of x, right? It all gets used up in either buying stuff or saving. What's cool is we can differentiate both sides of that equation. If the two sides are equal to each other, then their derivatives are going to be equal to each other too. So take a minute, see if you can figure out what the derivative of both sides is. That's right, the derivative of x is 1, and the derivative of the sum of those functions is the sum of the derivative of those functions. We call c prime of x the country's marginal propensity to consume, and s prime of x is the country's marginal propensity to save. If you think about it, it makes sense that those two functions are complementary, that they add to 1. If a country is earning X dollars, the propensity functions tell you how likely the people of the country are to spend and how likely they are to save. And since they're doing one or the other, their sum should be 100%. All right, that's it for 2.4. There's only 13 homework problems. As you can see, I got a little crazy with the animations and stuff. I think the videos are getting a little bit better. Sometimes I have to record outside because there's too many people in my house. Okay, love you guys. Have fun with your homework. Bye.